Alright, so you ready for an easy one? Okay, so section 6.2, probably the easiest thing that you will do in this class. Okay? And what's going to happen in this class, in this section, is basically, the big news is you take the average value of a function. Average value of a function. Now what do I mean by that? I mean the average y value, of a function. That's what I mean by that. Okay? So here's a function on some interval from a to b. J, does it matter if it's continuous or not? Oh yeah, of course it has to be continuous. So the idea here is across here somewhere there's some average height, maybe it's not, it's like clearly not up there. That's stupid. Clearly it's not down here. That's ridiculous. It's probably going to be somewhere, I don't know, in this region. Does that make sense? I mean, somewhere in that ballpark, that looks like it might be the average height. Well, check this out. How about I do this? How about this is f of x? What would I get if I took f of x and integrated it from a to b? Well, of course, I would get area. Okay? Now, obviously, we've been doing that a lot. What if I told you that area of a rectangle, of course, is width times height, or whatever you want to call it, right? That's equal to, so h times w is equal to area. Are you with me? Could I solve for h here, the height? Well, I feel like you could. It would be divided by the width. Does that make sense? Well, wait a minute. What's the width of this box? Well, friend, it goes from a to b, so the width is simply b minus a. And so what we're going to see is this. The integral from a to b of f of x dx divided by b minus a is what the book refers to as the average value of the function. Okay? Now, the game is at least one time between a and b, there's at least one place that has that average value. In this case, there might be two places where it does. You know, if we draw a different function, it might look something like this one. And in this case, from a to b, well, this is the area here, if you will, right? That's the area. If a person were to, I don't know, draw a line somewhere across in here somewhere, in essence, you could chop this little bit off right there and plunk it into here, and you will have created yourself a rectangle, are you with me? With a width of b minus a and a height of the average value. That is literally all there is to this thing. So I'm going to do several of those, and we're going to see what's what. So here, for instance, check this out. Suppose you had, the function was, I don't know, 3x squared minus 2. I'm going to do a couple of nice easy ones just because I can. I want to integrate this baby on the interval from 0 to 10, let's just say, for a good time. So it'd be the integral from 0 to 10. It'd be 3x squared minus 2x plus 5 dx, which of course is x cubed minus x squared plus 5x from 0 to 10. So that'd be 1,000 minus 100 plus 50. And of course, 0 on the bottom end, that'd be 1,000. And no, it wouldn't be 950, wouldn't it? 950. Nice. That is the area. Well, that's cool. What if I take the area, 950, and divide it by 10? I would get 95. This is the average height. Well, how do you know if you're right, Jay? That's a great question. Let's go see if Desmos can help us out here. Desmos. And let's type in the function. So it was 3x squared plus 2x plus 5. And let's make it projector mode. And while we're at it, let's put in x equals 0. Let's just put in these vertical lines. And let's put in x equals 10. Sweet. Now, you're like, wow, that's way up there. It is way up there. That is way up there, dude. And so if you look at it, I mean, look how high it goes. Good grief. It goes all the way up to there somewhere, 325. And as you know, at the bottom, goodness sakes, at the bottom it's, come on, give it to me. At the bottom it has a height of 5, obviously, yes? What's the average value across there? Well, we were told the average value is y equals 95. And so what I want to say is this. Let me back this out a ways. So I'm going to change my window just a skosh. I'm going to go 0 to 10 because that's the interval we're actually looking at. And we'll have this baby go from 0 on the bottom end down here. So just so I want to be able to see it, that's all. I mean, it doesn't change my answer or anything. I just think it makes my life simpler if I can actually see what I'm looking at. There we go. Cool. So as you can see, everything below the red axis, below the red line, is the area of the function. And this upper triangle piece, what we're saying is we can cut that part off. Oh, shoot. Darn it. And we can stick it down here in this piece down in here. Darn it. Darn it. Can I undo that? Shoot. One moment, please. I think I can undo. Yes, I can. Good for me. Okay, there it is. And so let me see if I can do a little snibbiting here. Snippet tool. Snipping tool. And voila. Voila. We can do it. We can do it. Bam! So what we're saying is we can take this piece up here and it should fit, you see, down in there. And it does. And it creates a rectangle that has a height of 95 and a width of 10. That's what we're saying by this. It's all there is to it. Are you with me? That's pretty cool. Now you're like, well, wait a minute, Jay. I feel like the equation f of x equals 3x cubed, or squared rather, plus 2x plus 5, literally, because it's continuous, has to equal that average value at some point, yes? Well, how am I going to do that, Jay? Well, I'm going to take it, and I'm going to set it equal to that average value. Now, is it possible it crosses it more than once? Well, of course it is. How do you solve this equation? Well, if you were doing this old school, you know, you could minus it over here and do the quadratic formula. Boy, doesn't that sound like a good time. You could graph this thing, whatever. Interesting to note, watch carefully. I'm going to do it anyways, just for fun here. Negative 2 plus or minus the square root of 4 minus 4 times 4 times 90 is 360. 360 times 3 is 1080, and it's negative, so it's positive 1080. All over 6. So this plus this is, you know, it's 1084. Square root of 1084. I don't know what that is. I'll look it up momentarily. And so, oh Betsy, the square root of 1084 is 32.9. So that's negative 2 plus or minus 32.9 over 6. If you add them, you're going to get 30 divided by 9, which is basically 5. And if you subtract them, you're going to get negative 34 divided by 6 is negative like 5.5-ish. Okay, this is without a calculator. Now come back on this graph over here, friends. Guess what? One of those values we just found, one of them has to be on the interval in question. And right there, somewhere, come on, give it to me. Right here somewhere. Oh, look at that, 5.154. Jay, how do we get that? Well, remember it was 32 divided by, was it 32 divided? No, was it 34? No, it was 30.9 divided by 6. 5.15. Huh? 5.15. Huh? Isn't that cool? Nice. That is where it equals. But you're like, Jay, there's two of them. That's right. The other one is over here, and we were right still. There it is. But notice it's not in my interval. Okay? So we were interested in the interval from 0 to 10. Where does it take on that average value? What you just found right there is what is referred to often as the mean value theorem. Okay? And in essence, what it is, in like lay people's terms, so that you know you can follow along with it, is simply this: that if you have a continuous function, which obviously we do, it's continuous on AB, function on AB. By the way, can it be discontinuous everywhere else? Sure, but on A to B it must be continuous. And it takes on some average value on that interval. It will happen at least one x value. What will I do? I'll take my function and I'll set it equal to the average value and I'll solve it. Okay? Now, that's how I like to think about it. This is what the actual function says. It says f of x is continuous. Sweet. On AB. Sweet. Then there exists a value c between a and b. So here's a and b. These are x values. X values. There will be a c on this interval somewhere between those two guys, such that f of c is equal to the average value. Okay, there exists at least one c such that that's true. Okay, that's it. That's all there is to the mean value theorem, or the average value theorem. Okay, now we're going to do a couple more examples of these because it doesn't take very much time and we kind of enjoy them. They're kind of a good time. Oh, how about this one here? I'm running low on inspiration this evening. Oh yeah, I suppose that would work, sure. Let's do it from x squared plus 3 sine x minus 2 square root of x. I don't know. What do you say? What do we say we find the average value somewhere between 4 and, I don't know, 9, I guess. Okay. So if I'm going to find the average value, I'm simply going to do this. And we're going to say this is the average value. So it's going to be x cubed over 3 minus 3 cosine x, because that's where sine came from, minus, that's 2x to the 1/2 currently. So that's going to be x to the 3/2 times 2/3. So it's going to be x cubed over 3 minus 3 cosine x minus 4/3 x to the 3/2 from 4 to 9. And divide out when you're finished. Okay? So cool, there it is. So let's plug in some values. So we were interested in 4. Oops. So, oh shoot. I almost forgot. I showed you this little cute trick and then I didn't show it to you correctly. Here, I'm sorry. So again, I do this a lot on Desmos. I just find it is kind of nice. Let's plug in 4. Again, this is my lower end. That's 12.627. 12.627. On the upper end, put a 9 in there. 209.7. 209.7. And when you minus them, you will get whatever, and just take that answer and divide it by 5. So 209 minus that would be what? 297, I guess? No. Yeah, 297. Or 197 rather. 197 roughly. roughly 197 divided by 5. 5 goes into that 30, 15, 47, 39, and 0.4-ish. This would be roughly your average value. Again, you use a calculator. I'm just doing it by hand. Okay? So let's go look at that, see if that seems reasonable. So let's see here. It was x squared, and it was plus 3 sine x, and then it was minus 2 square root of x, I think. And I said on the interval from 4 to 9. From 4 up to 9, which is right here. So I'm going to go ahead and graph those because I find that it's easier to see it that way. And x equal 9. Cool. So clearly the average value in this region is clearly going to be somewhere down here below 50. I mean, I don't know. You tell me. Y equals 50. That seems too high. Are you with me? Seems like this area up here above the black will more than fit in down here. Shoot, darn it. Okay, so then maybe I'm like, well, maybe I'll make it a little smaller, like, I don't know, 39.4 or something. Oh! Now it looks like this piece that's above the black line will actually fit inside of this hollow below the black line down here. So I would buy that for a nickel. Good job. Now, here's my question then, of course. That sounds like a good average value. Well, where will it occur? I don't know. 39.4 is equal to x squared plus 3 sine x minus 2 square root of x. Oops, square root of x. Now, Jay, how do I solve that problem? I'll tell you what, you solve it very carefully because you can't solve that guy any way we've ever done it before because that's just not what we teach. You know, you can't do it. And so there is our average value of a function right there, yes? Okay, there it is, right there. And so that's my actual function, is x squared plus 3 sine x. That's the original function. Okay. And I set it, you'll notice, equal to 39.4. Where they cross right there, 6.603, that is where it actually takes on that it takes on the average value. And again, it must occur between our endpoints. Our endpoints were 4 and 9 this time. 6 lies in the middle there somewhere. Doesn't have to be exactly in the middle. It needs to be in between these guys. So x equals 6. What did I say? 09? 6.6. I'm sorry, 6.6. Okay. I'm going to give you one here that's kind of interesting. So actually I'm going to graph it just for a good time. I'm just going to start off with a graph, I think, because I want to make it interesting. So x to the 4th minus 3x cubed minus x plus 2. Zoom. Oh, nice. Let's go from 1 to 3. Shut up. Look at that right now. That red line is entirely below the x-axis on that interval. Are you with me? What does that say about my average value? It better be negative. Okay? So let's try this thing. So it's x to the 4th minus 3x cubed minus x plus 2. And again on the interval from 1 to 3. And then simply divide out by 2 because 3 minus 1 is 2. So it's x to the 5th over 5 minus 3/4 x to the 4th minus x to the 2 over 2 plus 2x from 1 to 3. Can't really do that in my head. I mean, I kind of could, I guess, but I'm not going to. And so I'm just going to go stick that baby into Desmos. Okay, so over here, I'm just going to go ahead and put it in like this. X to the 5th divided by 5 minus 0.75 x to the 4th minus 0.5x plus 2x. Okay. Oops. That's the x squared. This x squared, sorry. And then of course I messed it up again. What I wanted to show you was using the A. I get so excited I'm doing math, I forget sometimes to use my little A. There we go. Add a slider. So my sliders are 1, which is 0.95. It just happened weird there. X to the 5th minus 3/4 minus half x to x. Okay, well it's fine I guess. It just seems odd. It just seems disturbing. But anyways, and then I'm going to put in a 3, negative 10.65. That's actually right. It just bothered. I don't know why that bothered me. So negative 10.65 on the one end minus 0.95 on the other end divided by 2. So shoot darn. So negative 52.8. That's not right. There should be a decimal there, Jay. There you go. Negative 5.8. So our average value here is negative 5.8. Is our average value. By the way, this is a y value. Okay. The question is, where does that hit our graph? Now notice originally I had screwed this up, and I thought what I wanted was y equals negative 58. Okay, oops, y equals negative 58. Now, you're like, Jay, that, I don't even see it, that red line. It's way down there. Yeah, it is way down there, yo. And if you scroll down here, you'll see it, and you're like, wait, that doesn't cross my function. It sure does not cross your function. That can't be the average value. That's how I knew I was weird. So then you put that 0.8 in that point in there. Oh, look! Nice! It crosses it 2 times. It crosses it there and there. In other words, there were 2 places where you had the average value. Now watch me do this, please. What I'm going to do, okay, is I'm going to copy this thing over to my other document here. I think maybe I am. Snippet tool. Let's do a new one. And let's cut and paste and whatever. And copy and boom. Come on, close. And yes, and then let's paste. Cool. So what we're saying is this. We can take this part in here. Right here, yes. And we can put part of it in here. And we can put part of it in here, and we've created ourselves a rectangle. Are you with me? Nice. A rectangle that has an area of whatever I said it was. Okay. And then it's 1 to, what did I say, 1 to 4? 1 to 3. 1 to 3. So we'd have a from 1 to 3, so it's 2 units wide. We know that from here to here is 5.8. That means your area is equal to 2 times negative 5.8. Sorry about that. Negative 5.8. Be negative 11.6. Interesting. You'll notice that sometimes in calculus you'll hear me talk about, does that seem reasonable? Well, let me ask you this question. Okay? I don't know, something like this. Here's 2, 3. And 1, 2, 3, 4. Dot. Jay, what does that look like that could be the average? What could do? I'm sorry, what does that look like the area could be of that value? Some of you might say, I don't know, but I feel like if you cut it about here-ish and took this triangle up here and slapped it into here somewhere, are you with me? Then I would have created a box. Does that make sense? And so if this were here, and let's say this is 1.5, let's just say it's approximately 1.5, then if I approximate this as my average height and then times it by the width, this is approximately the same as the integral from a to b, or from 0 to 3 in this case, of f of x dx. And that actually comes up in not calculus, you idiot, in physics. So in physics, you might recall, if you had a linear function like this for velocity, it's linear, it keeps getting bigger by the same amount. If you start here at 0 and you come across over to here somewhere, and again, if you've had physics, we always talk about linear velocity means you have constant acceleration. Constant acceleration. If this is 0 seconds and this is 5 seconds across there, let me ask you this. If he was going 10 miles an hour initially and he ends up going, I don't know, 30 miles an hour, what was his average rate of speed over that interval? Well, take a rocket surgeon to see that 20 would be the exact average. Yes, that would be F average, or V average, I suppose, would be equal to 20. 20 times 5, well, 20 times 5, this is miles per hour times hours, this would come out to be 100 miles. Okay. Now, it turns out that's how we actually do that in physics, because it's maybe been a while for you. You might remember that VF is equal to V sub O plus AT. And so what you'll end up with is you'll end up with this deal here like this, and you're like, okay, cool, this is V sub O here, the initial velocity, and then over here somewhere we have a final velocity, and then here you have a time, some distance and some amount of time from 0 to 2, from 1 to 7, whatever it is. Okay, and so if you think about that, how would you find this area? Well, back in my day, people would say, well, Jay, you need to find the area of that parallelogram. And they're right. They would say V sub O plus V sub F times T. Now, there's a couple of interesting things to do with this guy. Okay, well, what is that? V sub O plus V sub F divided by 2. That is literally the definition of average velocity times time. Does that make sense? And so that's the same idea here. So it is fairly useful. We use that quite a bit. I use it to check myself. Does that even seem like a reasonable, possible function? Okay? Give me another one here. So let's say I'm doing this problem. I got a 3 thing going on tonight, and I apologize. Sometimes I just don't really think ahead. And I'm going to do some nice easy ones here because I want just nice easy polynomials to integrate. Yes, this 100% works for any value of any function like that. I'm going to go from -3 to -1. There you go. So I want to find the average value over that region. It would be this guy divided by, how far apart are they? Well, it's -1 minus a -3. They are 2 units apart. So it's going to be 3x squared over 2 minus 4x cubed over 3 minus 2x to the 6th over 6 from -3 to -1. Divide the whole shebang by 2. Okay, remember, the width cannot be negative. That doesn't make sense. Okay? The height can, but the width can't be. That's just weird. So we're going to go 3a squared divided by 2 minus 4a to the 3rd. What are you doing? Shit. No. And that's just going to be x to the 6th divided by 3, right? You with me on that? Oh, not x, you idiot. Cool. And then I plug in my values. So I'm going to plug in -1. They get 2.5 on the top end. Minus, and let's put in -3. -193.5. -193.5 all over 2. That is 196 divided by 2 is 98. That would be our average value. So what I often do, but let's just see this for a minute. Let's actually just graph our original function here. So our original function was 3x minus 4x squared minus 2x to the 5th. Okay, and I'm going to then graph our x equals -3 and our x equals -1 routine. Hit OK and come back over here. So I want to know underneath of this orange line between here and going over here to the purple line, I don't know how much area I have. Well, notice that over to here, that was all a negative area in between there. It's a negative area, which is what we got. The other one's up around 190 something, I think, because we figured that out, didn't we, a minute ago? And somewhere up there around 200, they actually do cross. And I don't know, I have to zoom in a little bit, I guess, to see it. Somewhere in here they cross. Well, I'll tell you where they cross. Well, actually, no, I won't. So let me back this up a little bit. Let's just go from -3 to -1. Let's go from, say, -5 or something up to, yeah, 300 and something. Just about does the trick, yes? Not quite, but almost. Notice that most of our height is above the x-axis. If you told me that the average value was this, if I told you, hey, look, y equals 120, does that look reasonable? Does it look like this area that's above the red would fit in down here? And I say to you, I think that's a little too big. You're like, are you sure, Jay? What if I went 150? No, I know that's way too big. That is way too big. This stuff up here will more than fit in down here on the bottom. So what if I said to you it was 98? Oops. What if I told you it was 98? This stuff up here, would it fit in down here below there? Yeah, I'm pretty sure it would. That seems like a reasonable thing to say. Okay? And then of course, where do they equal? Where does that value of the average value occur? It occurs at -2.289, which makes sense because it's somewhere between -1 and -3. Does that make sense? Nice. Now, again, sometimes somebody might say to me, and I do this all the time, hey, let's find the integral of x sine x dx from 0 to 2. Now, I don't know what this is, so I'm going to use integration by parts. There's kind of a method to my madness here. So u is x, du is dx. dv, of course, is sine x dx. And v, of course, is negative cosine of x. So if you cross multiply, you're going to get negative cosine of x, and there's an x out front, minus the integral of, now it's already negative, so it's going to be positive cosine of x dx. And then where does cosine? Cosine is the integral, or the derivative of sine of x. And I plug in my 0 and my 2, and I see what happens. So this is going to be -2 cosine of 2, whatever the fink that is, plus the sine of 2, I don't know what those are yet, minus, this will be 0, this will be 0, so nothing. So I'm going to bring out the old calculator here. So I'm going to go negative 2 cosine 2 minus sine, is it plus? I think it's plus, isn't it? Plus sine 2. 1.74. That is my total area. Are you with me? So this answer is 1.74. Now, what I want to go look at is, what does that graph look like when I graph it? So I'm going to type in x sine x. And I'm going to hit home tab. And between x equals 0 and x equals 2, in this little region in here, does it look like there could be, this little region right there, does it look like you would believe there's 1.74 boxes of area? Well, remember there's a, let me snippet this dealy bob here. New. And copy and paste and boom. So this one right here basically is a whole one, yes? Okay. This one here plus this amount here, 1.74. Yeah, I'd probably buy that all right, probably. I think most of this right here, if you will, would fit in to here primarily, yes? It would fit into there pretty good. Well, how high would you draw it across, Jay? Well, I don't think this will fit all the way up to there. So I think I'm going to have to like draw it across somewhere through here. Are you with me? And then I take this little shaving off and throw it in here too while I'm at it. And the area would be the same. So when I look at that, I think to myself, well, alright, this is 2 units wide. And 2 units times something equals 1.74 is what you're saying to me, yes? The question is, what is that average value? So if I divide by 2, I'll get that it is equal to 88 point something, 0.88. Come on, give it to me. 0.87. Yeah, 0.87. I'd buy that for a nickel. Which is basically what I drew. That's 0.2, 0.4, 0.6, 0.8, and a little bit, yes? Nice. So this region in here is equivalent to, it's the same as all the area under here. They are identical. And so one of the main reasons I use the average value function is a way to check myself. It's a pretty neat way to go. Okay. Later on, we're going to look at some more numerical methods for solving integrals or approximating integrals. And in essence, what they do is, here's the function. You're going to draw boxes under this thing, right? Whatever. And maybe you're going to use the midpoint because you believe in it. Good for you. The essence of that is you are saying that this height right here in the middle is the quote-unquote average height of that rectangle times this dealy bob here, yes? But you're doing it a bunch of times. If I said I wanted to go from A to B and I wanted to do it one time, the idea would be, where would you draw the rectangle so that it would have the same area? Would you draw it like that? Nah, I feel like that's not, all this up here on top is not going to fit in right there. You with me? So I feel like I need to shift this baby up a skosh, maybe up into here somewhere. Okay? Now, does it look like it might fit? I think so, maybe. We'll find out in a jiffy. So there's this dude. Nice. And so the question is, would this stuff up here fit into here? Sure think it would. Therefore, what does that mean? It means that this y equals value here is your average value of function. And again, where does it happen? It occurs right there where the function is actually equal to that value. Okay? That is 6.2 in a nutshell. Well, it's a pretty good sized nutshell. I mean, like a giant walnut shell. I mean, it's pretty in-depth, friends. So I hope you enjoyed it. Let me know if you have any questions.